Hello and welcome to the second class of the DIY MIDI Controller Workshop. In this class we are going to build the circuit of our first MIDI controller. In this class you're going to learn how to design a circuit, how to use a breadboard, how to use buttons, how to use potentiometers, and get everything together to what's going to be the core of your first MIDI controller. So let's get started. So for this class, we are going to use things that are present in the Nerd Musician Arduino starter kit. You can go to the website and buy the kit, or if you want to buy from somewhere else, you can just use the list of components of this tutorial and be happy, okay? So the first thing we're going to need is the Arduino Uno. The Arduino Uno is the one that most of makers buy first. It's really good for beginners, and if you buy from us with our kit, this Arduino, you can be sure that you can make it a true USB MIDI class compliant device later on. I'm not going to enter into details why, because it takes some time, but this is the Arduino Uno, it's ideal for this project. And we are going to need a breadboard, which is this person here. It's going to be really useful throughout all your maker life. That's how you make prototypes you make using the breadboard. And we are going to need tactile buttons. They can come in different sizes, and those here are cool. We're going to need 3 of them, and we are going to use potentiometers. Those are called trim pots, but they work exactly in the same way as rotary potentiometers or slide potentiometers, and they're just smaller. It's good for us to work in a tiny breadboard. So we are going to need 2 potentiometers, linear potentiometers 10K, which is the B10K potentiometers. And last thing we need are jumpers. Jumpers are the best friends of the breadboard. We're going to use them to make the connections between the breadboard and the Arduino and the components. Okay, so now let's talk about each component individually. Okay, let's talk about these guys. So the first guy I want to introduce you is the tactile button. The tactile button can also be called a switch. So any SPST, which means single pole, single throw switch, is going to work for this. This means that any type of switch that you only, when you press, it allows the current to flow through the button, and when you release, it prevents the current to flow through the button, it's going to work, okay? So this thing here actually works in the same way as an arcade button. So most of buttons that you're going to use, they simply work exactly the same way. So in the prototype, we're going to use tactile buttons because they have those legs that are easy for us to snap in the breadboard, okay? But remember that they work in the same way as bigger brothers like arcade buttons. So keep this in mind that we are making a prototype, but once you understand the prototype, it's really easy to go to a complete project like in soldering wires and using better buttons, better potentiometers, and then go for the controller that you actually want to build. So how this works? Basically, imagine that we have just 2 legs. Why? Because this leg here is connected to this one here. So they're basically the same. It's kind of like a whoop, like a bridge. So inside here, they're making a bridge. Like whoop. Okay? So we just have this one in the left and this one in the right. So what happens? If you apply voltage in one leg, like 5 volts, and you apply ground in the other leg, what's going to happen is that once you press the button and you have this nice click, the current will flow through one leg to the other, right? And when you release the button, the current will not flow through the button. So basically, when you press, you allow the current to flow inside the button. So what happens is, inside the Arduino, we're going to tell every time we read 5 volts in a given pin, send a MIDI note. So it's going to read the 5 volts every time we press the button, because now we are allowing the current to flow through the button until the pin that we want in the Arduino. So this is pretty simple stuff. The second thing is the potentiometer. As I told you, this is a trim pot, but is the same thing as a rotary potentiometer or a slide potentiometer. So this thing here is actually a variable resistor, which means when you connect a resistor between the ground and the voltage, it's going to decrease the amount of voltage that pass through that resistor. It's just going to create a resistance between the ground and the voltage, right? So what this thing here does, you can control how much resistance this thing is going to have. So depending on how much you turn here the shaft, or if you have a slide potentiometer, how much you slide, it's going to change its resistance. And it depends on how much resistance this thing has. So for example, this is a B10K. So we're always going to use a B10K. It can be a B5K, other things, but just try to keep it simple, 5K or 10K. So forget the B for now. 10K means that it has 10,000 ohms of resistance. So we measure resistance in ohms, right? And the B means that it's linear. So you turn the potentiometer and then the reading is linear. Differently from potentiometers that you use in guitar volumes, for example, because when you turn the potentiometer in a guitar volume, the resistance actually does like this. It's logarithmic. And the reason it's logarithmic in a guitar is because our ears have a logarithmic response to sound. Just Google it, Wikipedia, it's your friend, okay? But for us, for MIDI, we don't want to have a logarithmic reading. We want to have a linear reading, okay? So B10K. So how it works? Notice that it has 3 legs. One leg we're going to connect to the ground, the left leg. The right leg we are going to connect to the 5 volts, and the middle leg we are going to connect to an analog pin. So a potentiometer is a variable resistor. What we want to do here is change how much current is coming from the 5 volts to the analog pin in the Arduino. So depending on how much we turn the shaft of the potentiometer, we are going to change how much voltage is actually arriving in the analog pin of the Arduino. So we are going to read this current that's arriving in the analog pin of the Arduino. So depending on how much we read, we will actually know where our potentiometer is. If it's in minimum, it's going to allow all the current to flow through the potentiometer. As we increase, it increases its resistance, then less current will arrive in our analog pin until we reach the maximum where no current will arrive. So in our analog pin, we will have a range that will go from 0 to 5 volts. And then in the Arduino, we have a analog to digital converter, which will convert this analog voltage into numbers, into digital information. So we will have a range that's from 0 to 5 volts in the analog domain, and we will have a range from 0 to 1023 in numbers in the Arduino. But don't worry about those numbers right now. Just know how to use this potentiometer and what it exactly is, okay? Okay, next is the breadboard. This is going to be our best friend while making prototypes, okay? So let's talk about the different parts of the breadboard, okay? It might be a little bit confusing, but just watch this how many times you need and let's go. So first, let me use this paper to isolate here. You can see that blue line, right? So imagine that below those holes there's a line, okay? Or a conductive material below all those holes, which means that they are actually all connected below this or inside this breadboard. Okay, so imagine that this whole rail here is one thing. This whole blue rail is one thing divided in many different holes. So imagine that's 7 different doors for the same room. Next, we have a different row here, which is the red row. So all the buttons in the red row are connected the same way. So imagine that here we have 2 different rooms. We have the blue room and we have the red room. The red room has that many doors and the blue room has that many doors, right? Then we have this. However, now this thing here, instead of being connected in this axis, let's say the x-axis, it's actually connected here. So let's turn here. So imagine that you can see a division here, right? It's really a division. So left is separate from right. So now we have from AB, you have like A, B, C, D, E, it's one room. And from F, G, H, I, J is another room. So this is one thing and this is one thing. So one room, that many doors, one room, that many doors. And then you go down, then you have another room. One room here, one room here. And here in this side is the same thing as this. So imagine that's just like we had 2 breadboards, okay? Okay, so now why we have this? You can see that here we have a minus sign and a plus sign. If we look our Arduino, the Arduino just has 1 ground, 2 and 3, and you just have 1 5-volt pin. However, sometimes we need to connect many components to the ground and many components to the 5 volts, but we just have limited pins in the Arduino. So what we do? For example, if I need many components in the ground, I'm going to connect 1 jumper here in the ground. Now we are using our jumpers, and I am going to connect in the blue rail. So what is happening now is that I am connecting the ground to this blue room. So remember that all those holes are connected. So what can I do now? Every time I need a component to be connected to the ground, instead of connecting to the Arduino, I am going to connect to this thing here. So if I have another component, then I can connect a component to one of those holes. And so for example, I'm going to put an LED here just to illustrate. So if I want to connect one leg of the LED to the ground, now I know that all this room here is connected to this leg. So all those holes here are making a connection to this leg. So I can connect a jumper here and a jumper in the ground rail. So now with the jumpers and the breadboard, so from ground is feeding out this blue rail. Then with this jumper here, I'm making a jump from the blue rail, which is the ground, to this leg here, because all the holes in this axis here, in this part, which is number 10, they are all connected, right? So if I want to get 5 volts, also I'm going to do the same thing. And as we go forward, you're going to see how this thing here is useful. But that's how it works. It just makes our life way easier and adds many more connections to the same components, thankfully to all those holes that are in the same room. I hope that this room analogy made sense. Okay, now we need to design and implement our circuit. And for that, we're going to use a pretty handy software called fritzing. So you come to fritzing.org, I'll leave the link below, come to download, and download the version of the fritzing for your computer. So I already have it installed here. So what it does is that it allows you to actually drag and drop components and connect them with wires. This way it's easier for us to understand later on about our circuit. So let's try to do what we actually want to do. So first what we need is an Arduino, so I'll go to the Arduino tab and grab an Arduino Uno. Next, we need a breadboard, so I am going to look for a breadboard in the search. I'm going to drag this one. This one is too big, but here you can select the size, so half plus. Next thing we need is a button. So now what we want to do is connect our button in this orientation here, like this. And you see on fritzing. So look that the legs are like that, so we need to rotate and see what happens when we place in the breadboard. You see that now this is green and this is green, so it's highlighting the room that is using. So this means that now this is also divided, remember? So now this leg here, remember that's only one leg that's connected inside the button. Now it's connecting this room to this room. Now this whole rail here is one thing because now this leg here is connecting both. So everything, so anything that we connect in this rail will be connected to this leg of the button. So let's add more buttons. Now let's add a trim pot. So the way we are going to connect this trim pot here is this leg is going to go to the ground, this is going to go to the analog pin, and this to the 5 volts. Okay, so now notice that it did the same thing. So everything that's connected here is going to be connected to this leg, everything that's connected here is connected to this leg, and so on. So first thing we want to do is supply a ground and 5 volts to our breadboard. So I'm going to put a wire from the ground to the blue rail, and I'm going to color this black. If you press Command, you can just drag and do like that. Then I'm going to put 5 volts into my red rail, and I'm going to put this red. It's a common sense that black is ground and 5 volts or positive is always red. Next, we need to connect one leg of each button to the ground. And we need to connect the ground leg of the potentiometer to the ground too. Now we need to connect the 5 volts leg or the positive leg to the 5 volts rail. So now that we have the ground and the 5 volts figured out, we need to connect the components to the pins in the Arduino that will read their state. So remember, buttons in the digital pins and potentiometers in the analog pins. So let's start through digital 2. So I have my buttons now connected in digital pin 2, digital 3, and digital 4. Now we need to connect our potentiometers, the wiper pin, to our analog pins. So A0 and A1. Now it's easier for us to understand what we need to do in our actual circuit. So basically now we just need to mimic our fritzing circuit. So let's do that. So notice that I didn't place my buttons in the exact same place that I placed them in the fritzing circuit. Where you place them exactly in the breadboard doesn't really matter. What matters is that if you understand how the breadboard works and what does this thing actually mean. So now let's place the potentiometers. Okay, you can see that I adjusted the position of the buttons again, so you just don't get too much anxiety of that button that was in a weird position. So now we need to connect the jumpers. And there we go, this thing looks hairy, looks beautiful to me, and I hope you don't get intimidated by the amount of jumpers you need to use. With time you get used to. And if you don't have enough jumpers or if you don't have enough components, don't worry, because tomorrow in the next class I am going to teach you how you can actually adapt the code to the amount of components that you have. And if you want to use different types of components like rotary encoders, or if you want to add LED lights or different types of sensors, those are things that I cover in detail in my Making Music with Arduino. And there are some details about the connection here that I don't have time to explain in this class. So everything about how and why I'm doing this and how I'm writing the code and why I'm doing the circuit like that, I cover everything in the Making Music with Arduino. But I'm going to talk more about that after the third class, okay? So I hope you enjoyed this class, and in the next one we're going to put everything together with the code, where you're going to upload the code in the Arduino and make it into a MIDI controller. And I'm going to teach you how you can adapt my code to your own needs, so you can make it the way you want it. So, see you tomorrow.